Now that you all know what is a flip-flop and the applications of flip-flop, can you give me a definition as to why flip-flop, or give me a reasoning as to why flip-flop is so essential? Yes, can someone unmute and respond? Why is flip-flop essential?
So because you can control the outputs and get the desired outputs.
But basically, flip-flops are used for what?
So for holding data.
Correct. So if data is not held, is there any purpose in discussing with sequential circuits? No, right? Because we need to have memory in place. So that's the basic importance of having a flip-flop, right? So as you all know, okay, your master slave flip-flops are pulse triggered flip-flops. So what is pulse? Pulse is nothing but a low pulse and a high pulse. So you can either think of the rising edge, low to high, or you can think of the falling edge or negative edge, which is from high to low, right? So I think these concepts are clear to all of you, right, with regards to the pulse. Yes or no? So what kind of pulse is this? Is it rising edge or falling edge pulse?
Rising edge.
Rising edge, and also it's called a positive pulse. And this is a negative edge, and also it's called as falling edge. Right? Okay, so here you'll have your lower data, and here this is the higher level of amplitude. Okay, fine. So latches have immediate output response. Okay, so this is known as transparency. So which means as soon as you give an input, okay, so you can actually get your output just like your combinational circuits. So this may be necessary to sense the current state of a flip-flop while allowing new state information to be entered. So if I want to check what kind of information is available, for example, in XOR gate, what happens? It will check the inputs. So if the inputs are same, then it's going to be 0. If it's different, then it's going to be what? 1. So we will now look into the master slave flip-flop. Can someone tell me what is the value of SR flip-flop when the inputs are 1, 1? Previous lecture, we have extensively seen about the flip-flops alone, right? How is its truth table? Then what is its characteristic equation?
Sir, it won't work.
Rather than saying it won't work, can I have some other answer?
It's invalid, sir.
Invalid. Why is it invalid? Some reason, no, that we call
Because
it
it's an
invalid.
unstable state, sir.
Unstable state. So I cannot determine. Okay, so in a high state, I cannot determine in one state that is my output 1 or is it 0. So it's very unstable and uncertain. I don't recommend such outputs when you work on circuits, right? So we need to know if we are going to get a low value or a high value. Okay, so that is one disadvantage here. So in this SR flip-flop, we have two sections, one the master section and the other one the slave section. So why we call it master slave? Because it's one after the other. First the master gets, and then it passes on the value to the slave. Okay. So as you can see here, information is entered into the master on one edge of a control signal and is transferred to the slave on the next edge, which means after the next clock pulse, okay, we can see that data transferring from master to the slave. Okay. Each section is a latch, so which means it is capable of holding the data. So here you can see you have S, R as inputs, clock is given as common, and one special thing to keep them, uh, on and off, the master on and slave off, is due to this inverter. Okay, so if I give a high clock here, then this will be low. Since the clock is low, which means I can say that this slave doesn't work, only the master works. So based on your type of inputs, okay, the outputs will actually appear at Q and Q bar. At the next clock cycle, whenever the clock, say for example here it is 1, then it becomes 0. So at that point of time, this will not work, and the values here will be passed on to the slave because clock becomes high here. So when the clock becomes high, which means the slave gets enabled. So the combination of S and R based on 0, 1, 0, 0, 1, 0, 1, 1, based on the combination and the truth table, it will appear at the output. Okay. So let us take the first case here. Till here, all of you have understood whatever I have told. Any doubts till this point of time?
No, sir.
Fine. Thank you, Rohit. So let us take case by case and we will try and understand. So let us take C is equal to 0. So what will happen when C is equal to 0? As I've always told you, when your clock is high, okay, when your clock is high, that is when your flip-flop, okay, will be enabled. So if I give a 0 here, which means I'm getting a 1 here, right? So in that case, the master is disabled. Any changes to SR, whatever value I give here to SR, it's as good as don't care, because this is anyway disabled. The master is disabled. And here slave is enabled. It is the same state as the master. Okay. So whatever state was there in the master previously, say if 0 was here and 1 is here, the same would be here, 0 and 1. So both of them will be in the same state when C is equal to 0. So ultimately when it is 0, 1, what kind of output am I going to get? What is going to appear at QS?
0, sir.
Correct. 0 is going to appear here, and the negation 1 is going to appear here, right? So that is for C is equal to 0 case. Now let us go with the next case. So the next case when C is equal to 1. So in this point, the reverse happens. The slave gets disabled and the master gets enabled. Okay. So when this is disabled, what will happen? Whatever values that we had previously, okay, say for example, we have 0 and 1, this will be retained because my clock now is 0 and my clock here is 1. So which means whatever values at SR will actually not pass on to the slave. Understood? So which means this is restricting itself from taking inputs because the clock is 0. So in this case, master is enabled. So that's why I've said it retains the state of the master. So whatever was there previously, okay, that same state will be kept constant. So here master is enabled, it responds to inputs. Now it is waiting for inputs. Since clock is 1, it is waiting and seeing as to what is going to be S and what is going to be R. It is ready to accept inputs. So changes in the state of master are not reflected in the disabled slave. So since here it is disabled, so whatever inputs, say for example, 1, 0 is given here, which means I should be getting 1 and 0. Now this 1 and 0 wouldn't pass. Okay, it will not pass. Why it won't pass? Why the values wouldn't pass?
Because clock is
Because
disabled.
clock is 0.
Clock is disabled. I am telling the slave not to work. I am telling the slave do not accept anything. You are not supposed to work at this point of time. Okay, so here the clock is high. The clock is in high state. Okay, so when clock is in high, your master is enabled. But at the same time, due to the work of this inverter, we are going to get a 0. The same 0 passes. So I am telling the slave do not work. It's like on and off switch for your slave and master. Clock is like on and off switch. So I hope this point is clear to all of you. Can I proceed?
Yes, sir.
Fine. So now we will see the next case. Next again when C is equal to 0. Okay. So now when C becomes 0, what happens is, as you all know, your master gets disabled. Whatever values were there, okay, those will pass on to the slave because slave is now enabled. So that's why I said it is acting like a latch. When it's not functioning, the values are held. So if the values are held, then it is called a latch. Latch means connecting to something, right? Holding on to something. So if it's holding a 0, then I can call it as a 0 latch. If it's holding a 1, then we can in simple terms term it as latch holding values 1. In general, we just term it as latch. So C is equal to 0, master is disabled, slave is enabled, and whatever values were here, new values that will get updated. Okay. For short periods during the rise times and fall times, both master and slave are disabled. Okay. So during a short moment of time, okay, when there is a transition between the rise and fall, okay, so at that point of time both master and slave are actually disabled for small amount of time. Okay, so you can summarize those with the help of these diagrams. So when it is a 0 0, okay, you can see that there's no change, and whatever is there in the memory, the same thing is retained. When it's a 0 1, 0 is the output. 1 0 1, 1 1 undefined or invalid. When it's a don't care, that is when clock is equal to 0, whatever is in the memory, the same state is retained. Okay, the same state is retained. Now we have understood the truth table. Now let us look into the diagrams here. So at this point of time, when your master is disabled, okay, so because we are giving a low value, okay, so till here the master is disabled and slave is enabled. Okay, so it's reverse. Why is the reverse happening? Just because of this inverter. Okay, so this is the clock cycle. Always you should remember, up till one point we consider it low, and once it reaches or goes beyond that point, then we treat it as high. Say if my, I think all of you are aware of this threshold voltage, right? 0.7. threshold voltage. So even if the value is about 0.6, still your transistor is in off state. Once it crosses 0.7, then only it will start conducting. Okay, so here also you can imagine the same thing. Okay, so at this point of time, your clock is actually rising. So during this time, okay, during this time there will be a lot of changes happening. Okay, so from here, okay, you can just yeah, till this point you can see that your master is disabled. Okay, and till this point you can see that your slave is enabled. Okay, so there is a kind of transition that is happening, between these two. Okay, between these two there is a kind of transition that is happening. So it is during this time that both are temporarily they are turned off and on. Okay, so because it's an intermediate value. Okay, right. Then at this higher point, okay, at this high point, so I can say that my clock is 1. So when my clock is 1, my master is enabled and my slave is disabled. So this will go on, okay, even though the value is lowering a little. Okay, see, the highest point is here, right? Even though the value is lowering a little, what is happening? The master is still in disabled mode, okay, and the slave gets enabled only when it reaches this point. Okay, so till then this is a region, this is a dark region, okay, where there is a switching that is happening between master and slave. So that is the delay that happens inbuilt gates with the inbuilt gates. So have you all understood this concept, students? Now, let us see if SR is equal to 1, the signal goes from high to low. We are in an unpredictable state. Okay, so this can cause something called metastable state. Okay, slave takes on state of the master at T4. So at T4, whatever values were there in the master, okay, previous values, that will be passed on. So previous values will be passed on to the slave only when it is enabled. Okay, so as you all know, this symbol, okay, pulse symbol indicates that uh, it is enabled when C is equal to 1 and the state of the master is transferred to slave at the end of the pulse period. So it will wait till the pulse is high. So when it starts reducing, okay, that is when your slave will start getting enabled. Okay, so this is also called as postponed output because we are getting the output at at the next clock cycle, not immediate, right? So summarizing all of these, okay, you will be able to see this timing diagram. So here what you can do is you can actually put values. Okay, here 0 0, clock is also 0. So whatever is there in the memory, the same thing will be there. So initially let us say 0 was there, so 0 will be retained. Okay, and for the slave, okay, that value will come later on when, let me just, okay, so this value is passed, this 0 is passed here from the master to the slave. Okay. This 0 that you see will actually come here in the next clock cycle. Okay. So this is happening in the previous clock cycle. These values are passed in the next clock cycle. Are you all able to understand, students? Yes. That's
So
why
why
you,
that delay, sir?
the delay is because of your inverter, right? Because master will work at one time, slave will not work at that time, right? Both are not working at the same time. So what is going to happen in the next clock cycle only? It is going to transfer the values, isn't it? So we are waiting for the next clock cycle. So when this goes low, what will happen? Your master will get, okay. So these values that you see, okay. Yeah, actually we should take reference, just a moment. We have to take, not with respect to this, we have to take with respect to clock. Just a moment, yeah, clock. So here, okay. So that's why you can see whatever values are here, okay, whatever values are here, it is passed on. See, these values are passed on here to the slave, but at the next clock cycle. So you can see that there is a small shift between the first master and the second slave. Yes or no? Correct. Your understanding?
Yes, sir.
Yeah. See, this is ending here. Okay, this is ending here. So which means even at slave, it should have ended here, but it's not happening. Instead, what is happening? We are seeing that it is getting delayed by this amount of time. So this total thing is your delay. So it's waiting for the next clock cycle. In the next clock cycle only, it is passing on the values. Okay. So you can actually put a logical line, as I always tell you, with respect to the clock for the high and low value, and it will be easy for you to understand. Okay. So you can put one here. You can either put at the rising edge or the falling edge. So with reference to clock, you have to see the values. Okay. So all these values here, just a moment. Okay. So all these values that are available here will be passed on in the next clock cycle. Okay. So you can see that, this is over at least about 75%, but here, it has just started. It has just started. The values have just started. Right? Can you understand what I'm trying to say? Here you can see that 75% is over, but here probably 25 to 30% of the pulse is passed on to the slave. So this is happening because of the inverter. The inverter keeps one of them active, right? So if the master is active, the slave wouldn't be active. If the slave is active, the master wouldn't be active. So it is waiting for the next clock cycle to be enabled and disabled. Have you all understood this concept? Yes.
Yes, sir.
Yeah. So in order to understand that, this diagram will actually help you a lot. Okay. So you need to really look into this diagram, and here you'll be able to understand exactly, okay, in this diagram exactly as to what is happening. Okay. So you can see that master is disabled. Here slave is enabled. Okay, because it's a low value. Okay. Next, I will give a high value here. Master is enabled, slave is disabled. Next, I will give a low value. So when I give a low value, slave is enabled, master is disabled. So accordingly, the values keep passing from the master to the slave. Always first is master and then slave. That's why they hold the name master and slave respectively. Fine. Are these concepts understood? SR, master slave, SR flip flop.
Yes, sir.
Okay.